So we will now explore the additional options that we can utilize in this simulator. So here, if you check, um, these are the different um, sensors or even outputs that we can use in this simulator. So we have the switch. When we try to click this one, it will show us um, some information about this one, the slider switch. So the slider switch, if you go into the guide we have earlier, um, here the slider switch is actually um okay, this one, the slider switch. So here, this is the slider switch that we'll have. So here it tells us that it is an input. So whenever we try to click this, it will switch from true to false. So it's an input, so therefore we can control it, and then whatever the readings we can get from this switch, we can use it to do something else. Another example is for the push buttons. So we have push button E and B. So this is the push button A and the push button B. The next one is for the red LED. So as I have demonstrated earlier, this is the red LED here. The next is the sound sensor. So the sound sensor is currently not implemented, but they are trying to, if we want to, we can at least plus one the feature addition issue in the GitHub. So it's still to be worked by the developers. Next is the temperature sensor. So here it is an input, so that means it will provide us some data. But since this is just a simulator, it it allows us to at least manually manually adjust the current readings that it will acquire, like this one here. So I can do it something like this one. Same with the light sensor also, which is also an input. So we can just simulate the readings from 0 up to 320. Then now we have here the neopixels. So the neopixels are this, as I mentioned earlier, the 10 LEDs that's situated here and here. So and it's also an output. We have speaker, which is another output, but it's not yet implemented. The motion sensor. So for this one, in the actual hardware, it can detect movement on the X, Y, Z axis. But since it's just a simulator, so you can just manually change the value of each one. We have the infrared transmitter and receiver. So it tells us that this is both input and output. If we check, excuse, if we check the diagram, so this is the infrared transmitter and this is the infrared receiver. So the idea is that if you still remember in the Lego, we have the ultrasonic sensor that will tell us if there's an object detected or there's a wall or something that's in front of the sensor. The principle for the infrared transmitter and receiver is that the transmitter will transmit an infrared signal, and whenever the signal bounces back from a certain object, it will return and will be received by the infrared receiver. So whenever the infrared receiver detects that signal, then it is able to identify that there's actually an object detected. Then lastly, we have the GPIO here, which can be an input or an output. So to illustrate further these functionalities, I would like to use the switch. We have here the sliding switch. If we go to the example, it's okay here. Let's go to the even for this one, the tutorial. Let's look for the sliding switch. Switch. Okay, this one. The sliding switch. So, okay, here it tells us that in this side it's true, and in this side it is false. So um, okay, so there's an example here that to use the switch, we'll just have um, to set cp.switch. So okay, to demonstrate that one, I'll need to create a new file. So to do that, we'll need to do the we'll use the command palette, Control Shift P, and then select device simulator express new file, and then we'll select for the circuit playground express. So here I can just actually copy this code. Okay, let's try to copy that one, then replace these things here, and then also we need to import time. Okay, so here so to explain the output, expected output, this will just print out the current status of the switch, and then it will update it for every 0.1 seconds. So in order for it to work, we need to save it first, and then okay, I'll call it cpe dash switch. Then okay, I think that's enough. CPE switch, save, and then okay, now I'll try to run this one. So okay, it tells us that it's currently false. Okay, I'll stop it for now, and I'll try to set it into 0.1 second. So that means whenever we change the value of the switch, it will reflect 1 second later. But I guess it's better because so that it will not load up or overload our system. So save it again, and then let's try to clear the output, and then now let's run. So okay, so initially the switch is in false state. If I click this, okay, it's not okay, if I click that, so the red one disappears. That means it moves the switch, so now it becomes true. And if I try to click it again, so the red appears. That means it's now back to the false state. So in that way we can use the switch. So I guess you got the idea behind it. So you can do the same for the red LED, for the I mean, you can use the same principle like for the temperature sensor, the light sensor, the motion sensor. So by just manually readjusting the values of this um, access. So in the next video, I will show you the activity that I will require you to do just for this discussion.